Why, hello! Here's a question for us. It looks like it is a dilution. How many grams of potassium permanganate are needed to prepare 100 mLs of a solution such that 1 teaspoonful diluted to 1 liter produces a 1 to 10,000 solution? I'm thinking, let's first think about and imagine what is being asked in this question. How many grams of potassium permanganate are needed to prepare 100 mLs of a solution? So this is representing that sentence. How many grams of potassium permanganate are needed to prepare 100 mLs of a solution such that 1 teaspoonful, the same teaspoon is right here, 1 teaspoonful diluted to 1 liter. 1 liter is the final volume. They're going to QS it. Diluted to, up to 1 liter produces a ratio strength of 1 to 10,000 solution. We have mass. Well, we don't quite have mass yet. We're looking for mass in grams. We do not yet have a concentration for this original solution, but we do have a volume for the original solution. Notice that the final, what we're looking for, we still don't have grams, but we do have a ratio strength, which we can convert, and we do have a final volume. As with many calculation problems, there is more than one way to solve this problem. Since I noticed that this is a dilution problem, even though right now from the question we only have one concentration, and that would be this, the 1 to 10,000. We can actually find another concentration to represent this box here. The concentration would be X grams over 100 mLs. So I will add that right there. We can find two concentrations. Now, looks like we're going to change that ratio strength to grams per milliliter. And it looks like it would be most beneficial to use the C1V1 equals C2V2 formula. C stands for concentration and V stands for volume. We are going to try to fill in the blanks of C1V1 equals C2V2. But we're looking more specifically at that teaspoonful. You notice that the volume of 1 teaspoon is 5 milliliters. So we can use this as the volume. Concentration 1 will be the concentration of what is in the spoonful, and volume will be that teaspoon, which we know to be 5 milliliters. So I'm going to right now just already plug in my 5 milliliters for volume 1. We're not looking for this entire volume. We only want to know the teaspoonful, because in the question it says such that 1 teaspoonful will be diluted. So that's why we're focused just on this 1 teaspoonful. How do we find the concentration? How do we find C1 then? Well, the concentration of this little portion is the same concentration of the entire thing. Nothing has changed. So if we can find the concentration of this, we're just taking a little portion of that and moving it into our 1 liter. We found our concentration already, and here it is, X grams over 100 mLs. I will move that down here, so that represents concentration 1. Now for concentration 2 and volume 2, we will look at this entire thing here. The volume, we know 1 liter is the same thing as 100 mLs, and that was the final. They said diluted to up to 1,000 mLs or 1 liter. And for V2, that's where I'm replacing it. Now for C2, concentration 2, that's where this ratio strength comes in. Another way to write ratio strength would be the first number, we could write grams after that. And the second number, we could write milliliters. If we keep it just like that and just put 1 on top and 10,000 milliliters on the bottom, this is the exact same thing as 1 to 10,000 ratio strength. So I could use this as my concentration. In fact, I do want to use that because this grams per milliliter is the same as this grams per milliliter. So grams per milliliter on both sides can cross out, milliliters on both sides can cross out. My concentration 2 was for the multiply, divide, multiply, and divide. I come to 5x over 100, 1,000 over 10,000, and my final then is x equals 2 grams. So this x, which is 2 grams, is going to be represented by what was in the teaspoon. So 2 grams is also in this teaspoon, and it's the same 2 grams that is going to be dispersed throughout the liter. So if you get proficient at doing this, you can skip just to this end box here, and it can still provide a good visual for you, where the top teaspoonful would represent the initial C1V1, and the big box represents the final C2V2. I hope this helps. Have a great day.